So we didn't finish graphing the logarithm problem on our last video, so we're going to finish this up. We're just going to start from the beginning a little bit here. So this does have, so here are our graphs. So our growth function looks like this with asymptote left and right. Our decay function looks like that with an asymptote left and right. So the log shapes are the same shapes, just kind of a different direction, and that's it. So here's a log function, and the shape looks very similar to the growth, just kind of flipped kind of diagonally. And then the asymptotes up and down instead of left and right. And then same here, how it works with the decay. Looks very similar, just kind of moved around a little bit. And again, the asymptotes up and down out on the y-axis instead of the x-axis. So our step one here, I'm going to make a graph. And then 0 is the asymptote. So what makes this 0, so I'm going to highlight this in blue, okay, is our asymptote. So our asymptote is going to be positive 4. So we're going to go to positive 4 here. So 1, 2, 3, 4. We have positive 4. And that's going to create an asymptote right there. Okay? So that's step 1, finding that asymptote. And that's the 0 of the logarithm. And it goes up and down instead. Our next step is to do an XY chart. Now we have to have smart numbers. So I'm going to highlight this right here, that 4. That's going to tell us what numbers we can pick. So if we have a 4, so we're going to just do some notes on smart numbers. So smart numbers, because logarithms are full of decimals and we don't want decimals. So if I have a 4, the smart numbers are going to be 1, 4, 16, 64. Notice we're just timesing by 4 each time. So if I have like a 2, our smart numbers are going to be 1, 2, 4, 8, 16. Notice we're just multiplying by 2 each time. So if we have 3, it's going to be 1, 3, 9, 27. Notice they just times by that number over and over again. So these are the smart numbers that we need. So when I put numbers here, I want to make sure that this becomes the result. So that's what we're going to do, is we're going to have these results here. So we have 1, 4, and 16. So we want a 1, 4, and 16 here, but we have an x minus 4. So that means I need to make this a 5, and I need to make this a an 8. Yeah, an 8. And then I need to make this a 20. Okay, and that's going to give us my smart numbers. So let me show you what that means, okay? So we have the log 4 of, and we picked 5, 5 minus 4 plus 1. And we're going to put these together. So log 4 of 1 plus 1. So notice when we put these together, we got the 1 that we needed. And that same thing is going to go for the rest of ours, is that when we put them together, we're going to get that what we need. So let's say you don't know how to solve this. We're going to get our calculator out, and I'll show you here. So here, let's turn this on. All right, so you can see it. So this is the log base 4 of 1. This is log base 10, so we can't use that. But we can do a change of base. So we can do the natural log or the log. It doesn't matter what button you pick. So let's just do log of the top number, 1, divided by the bottom number, 4. Okay, and I'm going to enter, and that's going to give me the answer to that. And I'm going to hit plus 1. So this equals 1. Then I'm going to put this in, so we have the log base 4 of 8 minus 4 plus 1. Again, I'm going to put my parentheses together, so we have log 4, base 4 of plus 1. So notice when I put these together, I get a smart number on the list. And that's what's going to happen, is you want to pick numbers here that give you these numbers inside the logarithm. That way when you put the calculator, you're not getting decimals. Now if you picked a wrong number, that's fine, because you'll just get a decimal and you have to plot a decimal. So we're going to do log of the big number on top divided by log of the bottom number on bottom. So we have log 4, that comes from this 4 here, divided by the other log, which is 4. That's going to give us 1, and then we have to add 1 from the equation here, so plus 1. Okay, and that's going to give me 2, so this equals 2. And that's going to go here. You can probably guess what the next one's going to be, because we're picking smart numbers. So we're not just picking any numbers, we're picking smart numbers. So I'm going to pick 20. Again, the reason why I picked 20 is because when I subtract them, I get 16. And the numbers we want next to logarithms are multiplicative. So we want, if it's a 4, we want something that we can times 4 by itself to get. So again, if we're going to put this in the calculator, we're going to hit the log of the number on top, which is 16, divided by the number on bottom, which is log 4. I'm going to hit enter. I get 2, then don't forget to add the 1 in the equation. So I get 3. So we're going to put 3 there. Okay. Now I'll be honest, I don't know if my graph's going to go all the way up to this. So I'm just going to plot these 2 points. And that's why shapes are important, because we're not going to get all the points on here. So we got 5, and then y is 1. And then we have 8, so 5, 6, 7, 8, and then y is 2. Okay, so we have these 2 dots there. And the shape here, the 4 would be a growth, because it's larger than 1, so it's going to look like this here. So I'm going to have an arrow that starts down here and goes parallel, and then kind of hooks up. It's not the best drawing, but it works. Looks like that. And then domain range here, domain, okay. We go left until positive 4, and then we go right forever. The range is going to be up and down forever, so we got negative infinity to positive infinity. So notice when we did this last time, this was the number that changed, and it's still, but it was here, so it kind of switched places. So notice that very similar to our exponentials, where we have a lot of infinities and a number that is the asymptote. All right, so we're going to go to the next problem here. I'm going to go this one a little quicker. Okay, so step 1 is the asymptote. So that means we need to find the 0. So x plus 2 equals 0. So x equals negative 2. So that's going to be our asymptote is negative 2. So 1, 2. We have our dashed line at negative 2. Then we're going to make our XY chart, and we need smart numbers. So 2's smart numbers are 1, 2, 4, 8, 16, 32, and so on and so forth, just times by 2. So I want a 1 inside the parentheses. I have a 2, so I'm going to pick negative 1. And then I need a 2 inside the parentheses, so I'm going to pick a 0, and then I need a 4 inside the parentheses, so I'm going to pick I need a 4, so I'm going to pick a 2. So this plus 2 kind of just changes these. If there's no number there, you just pick those, because when we put them in, I just want to show you. So when I put negative 1 in, I'm going to get log 2 of 1 minus 3. So that's what we wanted. We wanted that 1 inside there. Now again, if you don't know, you can pick any numbers. You just have to use your calculator. So we have log of the number on top divided by the log of the number on bottom. This is called change of base, and then we got to subtract the 3. So we get negative 3. No, did we? I feel like we made a mistake somewhere. I gotta figure this out. Let me pause the video. Nope, we didn't make any mistakes. It's a good number. So I'm going to put a 2 in. Again, the reason why I'm putting it'll be I want a 2. I want a 2. So I'm going to put a 0 in. So when I add them, I get that 2. So then when I do this, I'm going to get negative 2. And you can probably guess what the next one is. It's going to be negative 1. So again, when you pick smart numbers, you're going to get really easy answers. If you don't pick smart numbers, you're going to get decimals, and that's fine. Like, you'll just have to plot decimals, which isn't as fun in my opinion, but that's okay. So we got negative 3, and then we have 0, negative 2. Then we have 2, negative 1. And then our shape here, this is a 2, so it's going to be a growth. So it's going to look something like this here. Okay, and that's going to be the shape of our graph. Okay, a little tricky. Very similar to what we've done before, though, just kind of because it starts parallel and goes up and around a little different direction. So domain and range, domain and range. So this goes left until -2. So this is the left. Goes right forever. Goes down forever. And then goes up forever, just slowly up. And there we go. That's our domain and range. Graphing these is a little complex, but it's a very important skill. So hopefully you can get through this. If you want to put these stuff in the calculator, you're gonna have to use change of base as well. So don't forget that how to put in the calculator is that change of base where you do the number on top divided by the number on bottom. So, all right, thanks. Have a good day.